Hi, my name is BrenoFFerreira, PhD student, and my supervisor José Maria Bueno. I'm going to talk about my research project, which consists in the study of methanol production towards the CO2 oxidation with copper-based catalysis. As we know, climate change is one of our biggest concerns, and it is most attributed to the increase of the concentration of carbon dioxide in our atmosphere. Therefore, the production of methanol by the transformation of the CO2 came as candidate for both reduce climate change impacts and provide a new kind of profitable reactions. There are several reactions that are able to transform the CO2 to methanol or other valuable products. One of them is hydrogenation reactions. When it comes to the production of the methanol, copper is related about 79% of the latest publication literature. The copper can interact with the oxygen at their surface, creating an interface of copper 1 and copper 0 sites, as shown in the previous study in the research group, which shown that the smaller the particle size is, the better the oxygen interaction, increase the copper 1 sites. The interface of copper 1 and copper 0 alone could act as active site for the conversion of CO2 to methanol. As in strategy to obtain a highly active material, the copper interface was enhanced with zirconia. Comprehended the whole of the copper interface at the CO2 activation for both copper silicate and copper zirconia is one of the main objectives of this study. The copper silicate material was synthesized following the ammonia evaporation process. After that, the same material was modified with 1% in mass with the zirconia. Both materials was tested in the same conditions, which was at the temperature of 180 degrees Celsius to 250 degrees at 30 bars with hydrogen and CO2 flow in the ratio of 3:1 ratio. When compared to material before and after the modification, there is no significant change when it comes to conversion of the CO2 to methanol, but we notice a biggest change when it comes to selectivity to methanol, going about 27% to 46% after the promotion. The yield increase for the material with zirconia indicate there is more active sites disposable along the material. Through the curve of the conversion and selectivity, it is evidence a change in the behavior of materials after the promotion. That change can be attributed to the formation of active interface between copper and zirconia that are able to activate the CO2 into carbonate species. That process is more stable and prevents the formation of the carbon monoxide, although did not lead to increase of the conversion. So we can conclude that both materials are active for the production of methanol, but the modification with zirconia leads to a significant increase of selectivity. The presence of zirconia can produce an active interface that prevents the competitive reaction observed by the selectivity behavior. It is important to mention that further characterizations and more reactions need to be done. Thank you all for listening so far.